Is this like trig identities?
I know, there's already, like, as I introduced this today, there's already a visceral reaction. You're like pizza over in the corner is hyperbolic. And Ash is asking about a sheet of things we have to memorize. Okay, so having calm down, okay? Let me walk you back from the ledge a little bit. Okay. So, I understand. Now, first of all, we should also say that there are a lot of people, when they hear the thought that we're going to be figuring identities, you think that's like, the answer's really good. You're not very sorry about that. When they think that we're going to be proving identities, a lot of people don't react that way. They react like with pleasure and delight. Right? I mean, so many of you enjoyed that experience, right? Especially as time will roll on, you'll look back at it and be like, that was really one of the highlights of my mathematical career in high school. Proving those are like puzzles, weren't they? Like rich puzzles. You don't feel that way, everyone?
Oh, I have a fun and interesting identity we can prove. Times. Great times.
I think they're being down.
No, here's the thing that will walk you back from the ledge a little bit here. There's only one thing you need to know in order to prove these, and that's this fact, which is really the definition of a factorial to some extent, right? That n factorial is equal to n times n minus 1 factorial. And of course that makes sense if you just plug a number in. You can see that that's really what we mean by a factorial in the first place. Isn't 6 factorial? Can't that also be written as 6 times 5 factorial? Right? Etc., etc. Or, you know, you could write it this way too. N plus 1 factorial is equal to n plus 1 times n factorial. Like that way too. That's just a consequence of the thing written above too. But really it's almost definitional, what we mean by factorial. So let's take a chance. They're not proving anything yet, but let's just take an opportunity to show, or to simplify this expression. And by simplify, I mean, can you write this without any factorials? Maybe using these properties, expand this out. Cancel some things out. And then write it without.
So that, I take that to the previous.
Huh?
I take that like.
It's not so bad, right?
Yeah.
See, I know, I told you.
I just,
Now this is problem number 1 though.
yeah. I think this is promising.
It's promising. I know, I feel that way too. Alright, so if maybe it goes without saying, but I mean, I hope you're starting to already see that n minus 1 factorial is like almost contained in n plus 1 factorial. Right? And n minus 1 factorial is a factor of n plus 1 factorial. So if you could expand out the top, you know, it would be n minus 1 times n minus 2 times n minus 3, etc. If we expand out the bottom, what is n plus 1 factorial? N plus 1 factorial is n plus 1 times n minus 1, etc. In some sense, the factorial just means like etc., right? Can we just stop wherever we like? And of course, wherever I like in this case means the very thing that I'd like to see that will cancel out, right? So I think we'd all agree that that is a nicer, better way of writing the original expression for almost any purpose. So yeah, I guess we're saying something more general here, right? That 6 factorial, we can think of that as being 6 times 5 factorial. Or you can also write as 6 times 5 times 4 factorial, right? You can just keep going and stop wherever you like. You know? That's kind of what we just did here. We expanded this out and stopped where we like. Let's try proving something using, again, this is really the only fact today that you're using is this idea that we can keep expanding a factorial. And the rest of the task is algebra. See how good you are at algebra. And we like proofs. Right? I mean, in some ways, it's just like the last problem with an answer key, right? Simplify this and just make sure you get n. Okay? When you do, rejoice. So go ahead and, I think it's pretty clear that we should start on the left-hand side. So start working with this until you get n. And you'll have to recall, of course, what we mean by a combination, n plus 1 choose 2. Build that into your formula for that. Did you get n yet? I'll buy you a little time here. So what is that? N plus 1 choose 2 is n plus 1 factorial over 2 factorial times n plus 1 minus 2 factorial. N choose 2 I think we worked with the other day and simplified, didn't we? Just by definition of what those things mean, we have that. It's maybe worth simplifying here too. So then apply the same trick we had on the last slide. Are you already starting to see where this is going to go? A couple steps ahead. N plus 1 factorial contains in it n minus 1 factorial, doesn't it? So expand it out until it cancels out. And do the same here. N factorial contains in it n minus 2 factorial, doesn't it? So n plus 1 factorial is n plus 1 times n times n minus 1, etc. over 2. That's n minus 1 factorial minus n times, well, I'll give you another second here to finish it. I don't want to steal all you're doing. When you get n, you're done. So n times n minus 1 times n minus 2 factorial, we can write in the numerator over here. And then this is the fun part, things cancel out. And then we just have algebra here. There's no more factorials here. We get n squared plus n over 2 minus n squared minus n over 2. Combining numerators, be careful with the sign. It gives n squared minus n squared and n plus n, which is 2n over 2, which is 2, which is n, which is the right-hand side, which is what we desired. QED if you like, right? Questions? Each time.
How do you get the n minus 2 in the numerator right there? Yeah.
Right there?
Yeah.
N factorial is n times n minus 1 times n minus 2 times n minus 3. That's like what n factorial means.
Oh.
So I just decided to use that idea and stop where it suited me. Okay? True, yeah. We do require that n be 2 or greater. Yeah, we need to make n be greater than 2 or equal to 2. Let's just pretend that that's what it said and move on, okay? Yeah, that's good, okay. All right, try this one. I'll have someone come up to the board and do it. And that person will be my very favorite student. My very favorite student. Anya. There you go. Remember, you got the answer key. Carol will help you. When you get n squared, you let it go.
Something Toronto. Can it just be on this because it kind of can do better on this than it would on this?
How's it going on you? I would say it's weaker than you ever.
Still be a C. I mean, no, yeah, be a C.
I mean, hey,
Better than the greatest. Well done.
That's what you should just write.
where's the ball go? I have like a
You gotta buy a tree.
The answer is one.
Wait, isn't that racist though? Great. I thought sides were always those are edgy.
Right. Let's keep trucking here. Did you get N squared? Everyone happy with that? Eventually, Anya will put that on the board over here. You'll be grateful when she does. Okay. All right. Let's prove something quickly that was introduced and used yesterday quite a bit. I think all along we've been having the suspicion, of course, that n choose r. The n choose r is the same as n choose n minus r, right? We've been saying that all along here. And yesterday we played fast and loose with that. We're like, oh, 13 choose 5, that's the same thing as 13 choose 8, whatever, it doesn't matter, right? So let's come down and prove that once and for all. It's pretty quick. Okay, so go ahead and prove that. Huh? What'd you say? Okay, good. That's correct.
Wait, what?
So maybe we start with the right-hand side. It's just a little more complicated. I don't know.
Did we not check the left? Oh, wait.
Anya's going to put it on the board when she's ready. She's going to do it.
Oh.
Did you get n squared, Dinesh?
No, I didn't.
Oh.
Okay, well, I need to finish.
Why are we starting on the
No,
right
because you
hand
got
side?
QED.
It's a little more complicated, maybe. I don't know. You can start on the left. Did you get n choose r yet?
You give me a friend.
Well, it really is only like 2 lines. I mean, the proof.
I need to write down
The proof writes. The proof writes itself. You'll see. There's almost nothing to do here, right? Honestly, it's almost, the result is almost it's just short of self-evident. The journey does count, you're right. Right, there's not much to do. But we just want to be able to establish that result we keep using yesterday.
Right now my ends
To prove it. This is what we've been using all along here. So what is that? N factorial over.
How do you guys do it? I just got stuck on the first step.
Oh, okay.
Now I got it.
The next thing I write down is going to be us being done with this.
QED?
No, no, just haven't finished the last second. I gotta check it on the audio.
I did, that's what this is. You choose for this? You say so.
All right, so what do we get here? N minus r factorial, and over here, r factorial, and what's that? And choose r. And that's the left-hand side. All right, one last proof. Save the best for last. This one's a little bit tricky. Stay with us. Buckle your seatbelt. Okay, here we go. That looks complicated. I think it's worth. I think it's good maybe to start on the left side. It looks maybe a little more complicated. See if we can combine these into that one.
Yeah, I'd like to start there too, Mr. James.
Thank you, Ethan. Don't do it. Don't do it. All right, little magic eraser on this too here. Is that okay? Okay. So far, so good. All right. Now, the reason that this is the trickiest one here, maybe to do today, is that you're looking at this and you want to maybe take an approach like we did in the last ones. You're thinking n minus r factorial is the factor of n factorial. Like if you expand n factorial enough, eventually this does cancel out, right? But we don't know where. That's the challenge. Like we're not sure exactly where. So that makes this a little tricky. So really the next recourse is to say like, well, if we can't do that, maybe we could combine these somehow to form a single expression, find a common denominator and all that. So let's work on that. But before we even do that, we might be thinking, what would we like to see once we do that? So let me just stop and do that real quick. What is it that we're trying to even see that when we're done, how will we know we're done? Well, we have n plus 1 factorial is what we want to see in the numerator over r plus 1 factorial times, what's n plus 1 minus r plus 1? All right, so this is what we'd like to see, and if we see it, we're done, okay? So let's start combining these fractions, but this is the critical moment. How will we combine these fractions? Certainly you could start multiplying by the things that aren't in this denominator, right? Okay. But let's be really thinking hard about what isn't in this denominator, what isn't in that denominator. Do you see a part here that's very similar? What? R factorial and r plus 1 factorial. Let's just concentrate on those for a second. How would we make, if that was the only thing we were worried about, how would we make one turn into the other? Which one would you like to multiply something by? Yeah, we'd like to multiply this fraction over here by r plus 1 over r plus 1, this guy, because then we'll have an r plus 1 factorial in both denominators. That'll be nice. Apply the same kind of thinking now. As you look at these, what denominator needs what? Which one has a deficit here? The right one is contained in this, right? Like the very next term of this, n minus r times, what is n minus r factorial? It's n minus r times n minus r minus 1, etc. So this needs what? We're going to multiply this fraction by n minus r over n minus r. So over here we're multiplying by r plus 1. over r plus 1. And over here we're multiplying by n minus r over n minus r. I'm going to just stick it in there if that's okay. And so up here, we'll just keep the numerator the same for now. We have that over, this is r plus 1 factorial, n minus r factorial, and so is this denominator, right? Now there's something else exciting about the fact that we now have a common denominator, besides the fact that we can add the fractions, and that's what? It's what? Ah, yeah, you're looking back at what we're looking for. It's not only common to these, but it's also the denominator we seek. Oh, this is really good news, which means the numerator just hopefully is the numerator we have up there. Yeah, and then what's the next irresistible thing to do up in the numerator? Yeah, even if you didn't have a direction to go in life, you'd just want to factor it because you would have that natural inclination. Right? The n factorial, yeah, you just are dying to factor it out just for fun. So what does that leave in the numerator if you factor out the... What happens when we factor out the n factorial here? We get an r plus 1 and n minus r. Now I'm going to have to snake up the side of the board here, I apologize. But what does the numerator give? It's n factorial times what is that? N plus 1. We're going to keep going up here. We're going to keep going the side here. But we're done, right? And you see it, right? What's n factorial times n plus 1? Which is exactly what we wanted to show. Right hand side. Probably the harder one that we've done today, right? I think you have one like that. Now, I want to invite you to think about something that we looked at yesterday and give you some perspective on today's lesson a little bit. In Pascal's triangle, you know that one of the defining properties that you might have seen even in whatever, in elementary school, in middle school, whenever you first heard about Pascal's triangle, is that this plus this equals this, right? I say that that's what we just proved.
What?
And choose R, which is this, plus n choose R plus 1, that is n same row, and n choose R, and n choose R plus 1 are in the same row in Pascal's triangle. They're just next to each other, right? N choose R plus R, n choose the thing next to it, is equal to next row. The next row's element plus 1, right? That's what we just proved. We just proved that property from Pascal's triangle combination. And we're done with the proof. I just thought I'd show you that visually we're proving that this guy plus this guy equals this guy, right?
On the second step, we went to the third. The r factorial is gone. What happened to it again?
From here to here? Sorry, from here to here?
Yeah.
So r plus 1 times r factorial
Yeah.
is r plus 1 factorial. Let's go the other way. What's r plus 1 factorial, you tell me? Isn't that r plus 1 times r times r minus 1 times... Yeah, so that's one of the things that's like I said, it's the only fact we're using today is this idea that we can like kind of accordion factorials, right? Anya, I told you could do it. Yes. Good work. All right, fare thee well. See you tomorrow. Of course, the quiz will be tomorrow, so we'll discuss this homework on Monday.